Let's have a quick look at the homework that you had. So question 6 was, the diagram shows a horizontal table in which a 2 kilogram mass is placed. A 4 kilogram mass and a 1 kilogram mass hang freely over the sides. The coefficient of friction between the 2 kilogram mass and the table is 1/2. So find the common acceleration and find the tension in each string. So the first thing I do is I'm going to look at each mass and the forces on each mass separately. So if I look at the 1 kilogram mass, it has 1g going down, okay, and then up there's going to be a tension, and I've called that T1. Then on the 4 kilogram mass, that has 4g going down, and I've called it T2 going up. Now, if you look at the weights, this is 1 kilogram and this is 4 kilograms. So the acceleration is going to be going that way because it's going to be pulling down. So your acceleration is up, over, and down. Now looking at the middle mass, we have a 2 kilogram mass. Okay, we know we have tension 2 going that way and tension 1 going that way. And because the acceleration is going to be going to the right, there's going to be friction going to the left. So you have to work out what the friction is. So to work out the friction, we know that the coefficient of friction is 1/2, and the friction is mu r, or mu multiplied by the normal. So that's 1/2 multiplied by the normal. We know there's no up or down movement, so the normal, which is going up, is going to be the same as the weight. So the normal is 2g, so the friction is 1/2 of 2g, so our friction is going to be g. So going back here, if we're going to resolve our forces, we know that F, force is mass times acceleration. So force is 1 times A. We also know what are the forces on it. Well, it's going in this direction, so it's going to be T1. What's pulling against it? 1g. So it's T1 minus g. And if my F here, so I can put 1A is equal to T1 minus g and get T1 equals A minus g. I'm going to go straight over to this one here, using the same two things. Force is mass times acceleration, so that's 4a. And then the force, remember it's going down this time, because that's the way it's going to be moving. So it's going to be 4g minus T2. So I can say that 4a is equal to 4g minus T2, and then T2 is 4g minus 4a. Now if I look at my middle one, so if I look at this middle one, I know that the force is mass times acceleration. So F is equal to 2a. I also know that it's going to be going that way. So there's going to be a pull that way, so that's T2. What's going to be going against it is your T1 and your friction. So its force is T2 minus T1 minus the friction. I can put these two equal to each other now, and I get 2a is equal to T2 minus T1 minus g. Then I go down here, I rewrite this line here, and I substitute in a plus g for T1, and I substitute in 4g minus 4a for T2, and I work out that a is equal to 2g over 7, or 2 over 7g, which is 2.8 meters per second squared. The second part of the question asks you to find the tension in each string, so you have to find T1 or T2. That is just a case of subbing in your A, your acceleration, which is 2.8, and your G, which is 9.8, into here. And you get your tension is 12.6 newtons. I should have put newtons there. And then do the same here, and you get 28 newtons.